Hello ladies and gentlemen, hope everyone is doing well today. So for this video we're going to continue on with section 5.4 and we're just going to focus on multiplying rational expressions, and it's going to relate to the material that we learned on Friday when it came to simplifying them, because it's going to make our process much easier when we deal with multiple terms being involved. Now if you think back to an example, say from pre-algebra, if you were to multiply two fractions, say 1/2 times 3 over 5, then that is going to be the same as 3 over 10. Because whenever you multiply fractions together, and this is also the same case when you deal with rational expressions, if you have A, B, C, and D representing mathematical expressions for your numerators and denominators respectively, then when you multiply two fractions, you're just multiplying horizontally across from each other. Because we can see that 1 times 3 gives us 3 here, and 2 times 5 gives us 10 here. And so this is going to be the general format that we use when we multiply rational expressions. And we just want to ensure that the denominator is not going to be equal to 0, and that's always going to be true for these examples that we work on. So if I take a look at this example on the bottom here, it's going to be the same sort of process as before. We'll just want to focus on each individual component one at a time. So if I multiply the two numbers together on the top, we get 56. If I multiply x to the 4th with x, that's just going to be x to the 5th. If you recall from chapter 3, when you use your properties of exponents, multiplying means you're just going to add the powers together, and that same mechanic is going to be applied to when we multiply the y's. And now we can just focus on the denominator, same sort of process as before. So we get 20, then x to the 8th, and then y to the 2nd, because there's no other y term that we have here. Now this is where you get to apply simplifying those expressions. So again, we just focus one component at a time. If you examine 56 and 20, you can tell that both of them are divisible by 4. So 20 divided by 4 gives you 5 over here, and then 56 divided by 4 is going to give you 14 up top. And now since you're dividing between these variables, then the exponents are going to subtract from each other. So we do a 5 minus 8 for x. That's going to be x to the -3rd. And then y to the 4th divided by y to the 2nd is going to give you y squared on bottom. Now if they did ask you to express these in terms of positive exponents, you recall that if you have something raised to a negative power, it's the same as putting it in the denominator of your expression. So that x to the 3rd is going to become positive when it gets moved down here. And so this turns out to be our final answer. Okay. Now that was a relatively easy case. Now let's take a look at some cases in which you have, say, trinomials or binomials being involved in your expressions. So before you actually multiply these types of problems out, it's a good idea to try to factor the numerators and denominators separately. And then we're going to put all of those expressions right next to each other. So when we take a look at this first one, we see that we can pull out a 3 as well as an x. So we get 3x, then 1 minus x up top. And then over on the bottom, we see that we have a quadratic, and the two numbers that multiply to a -5 and add to a +4 are going to be a +5 and a -1. A cool trick again, whenever you multiply two numbers to a negative but add to a positive, the factor that's the bigger number here is going to have the same sign as the middle term from your original expression. Okay. Now we see the denominator for this expression can't be factored, so we're just going to keep it as 3x, and then over here this one can factor again, so we can get an x plus 5 and an x minus 4. Okay? So now from here, all I'm going to do is just write this all as one single expression. So I get 3x, 1 minus x, and then over right next to it we have x plus 5 and x minus 4. And so we just do that same sort of thing with the denominator here. And now we just take a look to see which expressions we could cancel out. Now keep in mind again, you do want to make sure that the expressions are exactly the same in order to cancel out. So the 3x matches with the 3x down here, so those go away. That x plus 5's on the top and bottom go away. And there's actually one more step to this one as well, because notice how x minus 1 and 1 minus x, they look very similar. Here is just the same as a negative x plus 1 if you rearrange the terms. Because remember that addition It doesn't matter which order in which you add two things together. And now you may notice that the signs between both of these expressions are just flipped. So if you factor out a -1 from that expression up top, we're going to get an x minus 1 left over. And now from here, you're able to cancel those out. So all that you have left is just a -1 times x minus 4. And if you simplify that, you just get a negative x plus 4 right on the bottom. Okay. Now, this next example is a little bit different because now you're multiplying by just a whole number expression rather than it being a fraction. Well, the nice thing about expressions, if they don't have a denominator that seems apparent, you can just write that same expression and put it under the number 1. So we have x squared plus 3x plus 9 all over 1. Right. Now, we know that x plus 2 can't be factored at all. There are no two numbers that multiply to a positive 9 and add to a 3 in this case. However, you can actually factor this one here. And let me change the color of our pen to remind us of a factoring technique with this particular expression. Notice how you have x cubed minus 27. So here is a case in which you have a difference of perfect cubes. And there was a nice formula that we could use when it comes to factoring these expressions here. And that's just going to be a minus b times a squared plus ab plus b squared. And recall that a and b are just going to be the cubed roots of these two terms respectively. So the cubed root of x to the third is just going to be x, and that's going to be our a. And b is going to be the cubed root of 27, which is 3. Right? And so now if we were to plug those values into our formula just for that denominator, then we're still going to have an x plus 2 over on the top. And now down here, I do x minus b, so I'm going to have an x minus 3. And then over here, I'm going to have x squared plus 3 times x for that ab portion, so that's just going to be a 3x. And then plus b squared, which is 9. Okay. And we still have that second fraction remaining the same. And if you were to conjoin, both of those expressions together, then we're just going to get an x plus 2 times x squared plus 3x plus 9. Then over on the bottom, we just have x minus 3, and then parentheses x squared plus 3x plus 9. And so since these two expressions are exactly the same, they cancel out, and so we just have x plus 2 over x minus 3 for our final answer. Okay, and that's pretty much going to be the process for these types of questions here. Just keep in mind that you may want to factor both of the numerators and denominators separately before you put everything next to each other. That way you can see which factors will cancel out accordingly. So today's assignment is just going to deal with some more practice problems similar to these ones, and then on Tuesday we will go over how to divide rational expressions, and the process is going to be very similar when you multiply them. Hope you guys have a great rest of the day.